here. Do we need more proof? Shall I bring the other two also here to show you that I am a grandmother? So, despite of it, I left everything. No, it is meant for my children. I've got to give it to my students. This is what we did. So, what's the point of saying Happy Teacher's Day? It doesn't make any difference when you don't respect the teacher and what she's doing. Don't respect yourself. Forget about the teacher. I'm doing my duty. Finished. These people have not come. Achha, I will send the paper.
No.
Go and get that paper. Go get that paper and get the two chops, 2 pens also. What you were saying, Gary, something you were saying, no? And I told you shut up. Niyati is who now? I have to ask her, she had a very challenging question in her question paper and she lost 1 mark. And I don't know what that question is. But it will come, I'm quite sure it will come for you all also. I hope she comes to remember that question.
And she is just getting a bit late.
Let me be, but she has to come. Come. Thank you. Take this paper and pass it on. Sign all of it. Sign all. Come. This fellow, his parents came, but you did not come on Sunday. You're not well. And then your parents came, they came with nothing. They have brought your progress report. And I was not able to understand anything because I wanted to see where you lost your marks. I wanted those papers. As I said, group home, get home and get your file of all the papers. Some of them brought their papers to show you where you have lost your mark. But your father said, I don't have anything. He came with nothing. Where's the boy? The boy is also at home. Is it because of your mother's face? I remembered whom I was talking to. I'm talking about. I don't know your parents. But when you come with your parents, I know exactly how these are the parents. Because of your mother's face, you look at your mother, I said, yes, I think I know who this boy is. Okay, time fast. Fast. Time the full for both the lectures also. Okay, all right. Now we come to, I'll just do the revision of this chapter, chemical changes and reactions. Okay, so let us just generally speak. What is a chemical reaction? Not you. What is a chemical reaction? Yeah.
The reaction in which two or more reactants combine, react and give out products.
And form product. That is a general general definition. What is required for a reaction to take place, for a chemical reaction to take place? What are the factors that are required? Heat, yeah.
Light.
Light. Close your books. Heat, light, then?
Electricity.
Yes.
A catalyst.
Correct. Can you complete? Huh? Sound. Okay, then. Yes.
Close contact.
Close contact, then droop.
should be in molten state.
In the molten state, liquid state. Anything else?
They have to be mixed.
They have to be
Mixed.
they're in close contact means they're mixed. Okay, so these are the factors that are required for a chemical reaction to take place. Correct? All right. So again, I repeat, the factors are they should be first of all in very very close contact and in tiny particles, not big lumps, tiny particles and close contact. They should be mostly in the molten state. Okay, then you should need heat, electricity, light, catalyst, temperature, pressure. Pressure is what we're left out. Okay, so these are the factors that are required for a chemical reaction to take place. How do you know that a chemical reaction has taken place? How do you know that
Any change in state,
change in state, physical state, okay.
physical state, color,
Color,
color, and
one more,
effervescence may be produced.
that means the gas is evolved.
Yeah.
Okay, then next Ian, what else?
Sound might be produced.
Sound may be produced, what else?
Evolution of light.
Of light, sound, light,
Energy, evolution.
energy, what else?
Precipitate.
Precipitate. Precipitate is formed, not you, then what? Ian?
Acid.
Huh?
Acid will be formed.
Acid. Do you know that an acid is formed? Can you see? You only know that the products are formed. That's what he said already. Products are formed. Then what else?
Gassy word.
Gas is what she said. Evolution of a gas. All the conditions are completed. First of all, you have to say how is it formed. Then a reaction. Yeah, it's okay. And it sends. When a reaction takes place, how do we know that a reaction has taken place? Because first of all, brand new compounds are found. Okay, having their own properties, correct? All right, then you can say that there could be a color change, heat is evolved, when you touch the container, it is hot. Then you can say gases may be evolved, then you can say precipitate may be formed, okay? Then energy is evolved either in the form of heat, light, or sound. So this. Now, what are the different types of reactions that I have taught you? What are the different types of reaction that I have taught you? Very first type of reaction is what?
Direct combination.
Direct. What is another word for direct combination?
Synthesis.
Synthesis. Okay. So what is synthesis then?
Like when two or more reactants just form to make one product.
To make one or more. I didn't say one or more product.
One or
Exactly.
more.
Yeah.
For example,
Yeah.
2H2 plus O2 gives 2H2.
Gives you water. Correct. All right. Next one. So that next.
Decomposition.
Decomposition.
When one reactant reacts to form two or more, it like two or more compounds.
Listen to the word decomposition.
Decomposition.
What is decomposition?
One product reactant will form. It will like decompose.
Give me the simpler word for decompose. It's a very big word. I can't understand the meaning of decompose. Give me a simple
It will
word.
split.
Split up.
It will split up into two or more products.
Two or more.
Products.
Anything else further than that? Can you give me another
It
more?
won't be reversible.
Yeah, those two products will not
Will not combine to
to
form
give you the original
substance.
substance. Correct. That is the complete definition of decomposition. When one substance breaks up into its constituents and the two constituents don't combine to give you that original substance, that is said to be decomposition. What are the factors that bring about decomposition?
Heat,
Yes.
electricity, light.
Light. Okay. So give me an example of chemical reaction wherein heat is required for decomposition.
CaCO3 when heated it's CO2 and CaO.
Yeah. So when you are giving it heat, what is the decomposition reaction? Another form of
Thermal
decomposition because you're using heat. And when you're giving it heat, what is it? What type of reaction is that? You're giving it heat. Endotherm. You're giving it heat. You're giving it energy. Whether you're giving it in the form of heat, light, or electricity, it is energy. So these are all endothermic reactions. Okay. Next one. Give me an example of electrical decomposition.
H2O decomposes to H2 plus O2.
Correct. And the third one, photo.
HNO3. Argentinum.
Argentinum, you're okay, but we don't use that.
Ag plus
What is Ag? What is Ag? What is Ag? What is Ag?
Silver, sorry. Silver.
Only silver.
No, silver plus 9.
So what is the full? Give me the full name of the compound.
Silver.
Huh? Loudly.
Silver 9.
Huh? Then
Uh,
you.
Silver nitrate plus oxygen.
You. James.
AgCl.
No. Silver nitrate. Then what happens? What else? What happens to AgNO3?
Light is given.
Yeah. Huh?
Light is given.
Yeah. So then, what is light called?
Photochemical.
Okay. And then what is the product?
AgNO plus O2.
Ag.
NO.
AgNO3 will break up into what?
AgNO3. AgCl. Right.
Where is AgCl? AgNO3 only is there, no?
Camera.
Huh?
Camera.
Silver nitrate on decomposing materials. Silver nitrogen dioxide.
Silver only gives you silver and nitrogen dioxide. You have to balance the equation. Silver nitrate on exposure to light photo will give you silver and NO2, nitrogen dioxide. Is this clear? That is it. Now remember you had a question in your paper there you showed me and you were supposed to show the differences between what
decomposition and dissociation.
decomposition and dissociation. Okay. So that is what is the difference between decomposition and dissociation?
Dissociation is reversible, but decomposition is not reversible.
Also, yeah, dissociation, I had told you that. Dissociation is reversible, while decomposition is not reversible. Now, when decomposition takes place, let's pay attention. When decomposition takes place, the compound breaks up into its constituents. When dissociation takes place, the compound breaks up into ions, dissociation. Okay, dissociation, it breaks up into its ions. So NaCl, when it dissociates, it will give you sodium positive ion and chlorine negative ion. That's called dissociation. All right. All right. And decomposition is when the compound breaks up into its constituents, like calcium carbonate. It breaks up into calcium oxide and carbon dioxide. And calcium oxide plus carbon dioxide will combine together to give you your calcium carbonate.
Dissociation is always between like a form from compounds to ions.
From compound to
Ions.
obviously because the compound molecule contains the ions, one positive and one negative, will combine together to give you a molecule. That molecule is neutral. When that molecule breaks up, you get your positive and your negative ions. Yeah.
Now, dissociation reaction only occur in ionic form, compound which have ionic bonds.
Yes. No. That is dissociation. See what happens is you're coming into polar bonds and polarity. Don't do that, will come next year. You just remember the dissociation is breaking up into ions. Okay, that's it. Alright? We may not have ionic bonds. Dissociation means breaking up and forming ions. That is in your covalent compounds. What are covalent compounds that you all don't know? You know what covalent compounds are? You know what covalent compounds? See, okay, you'll know that ionic compounds are formed between metal and non-metal. Metal is positive, non-metal is negative. So when they are joined together, you are getting your sodium chloride. Okay, but the positive of sodium and the negative chlorine cancel each other and you got a molecule of sodium chloride. Okay, now when that molecule breaks, okay, the bond Na-Cl, that bond breaks, and automatically the ions are there. So that is just called breaking up. But when we say dissociation, okay, that is called say dissociation, you're breaking up. And ionization, What is ionization? Ionization is when the ions are formed. Now, what do you mean by ions are formed? If you're talking about, say, for instance, say, carbon and oxygen, both of them are non-metals, correct? So when they are combining, they are not donating, they are not accepting, they are sharing. They are sharing because there is no metal here to donate. The non-metal, if there is no donation, the non-metal doesn't accept anything. But the compound is formed, and the compound is formed by sharing. So this particular carbon dioxide is a molecule which is neutral. Now, what happens is when it breaks in the water, it will form ions. It will form ions, and that is called ionization. How it forms, when it forms, how that will come next year. But that ionization is not in your course. You are only asked to find out the difference between decomposition and dissociation. Decomposition, when one compound breaks up into its constituents and those two constituents do not combine to give you back the original. This is not a reversible reaction. But dissociation is when a compound breaks up into ions and the ions will combine to give you back the original compound. That is the difference between dissociation and decomposition. Is that clear now, all of you? Okay. Now, this is the change of state. Then also when a chemical reaction completes, if you have taken two solids, the reactions could be liquids, change of state, change of color, heat. Okay, heat is given out or absorbed, depending. Then of course you can say gas may be liberated or a pressure may be formed. So these are the different changes. So these are different observances when a chemical reaction has taken place. When we see all this, we know that a chemical reaction has taken place. Okay. Now, okay. What about the next step? So we finished with synthesis. We finished with decomposition. What's the next step of reaction that I've taught you?
Dissociation.
I finished with, no, I did not teach you dissociation. I taught you synthesis, I taught you decomposition, then I taught you, before that,
Displacement.
displacement. Who said displacement? You. Okay, what is meant by displacement?
The reaction in which an element takes place, changes its place with it changes its place with an element in a compound.
So you have to give some specifications of that element term
That element is like higher
in the reactivity series
higher than
than
the element in the compound.
in the compound. The element in the compound. Okay, that element has to be higher in the reactivity series than the element in the compound. So what is required for a displacement reaction to take place? What is required? What is required?
Displacement
Ah,
it has to be more reactive than the liquid.
that is okay, that's a condition. What is required? What is required?
A metal and a metal compound.
I would say a metal and a compound. A metal and a compound. Single and double. A metal and a compound. Correct? Now what is double decomposition? What is meant by double decomposition? Ian, you move on to one side. I want to say the video of this kind space. What is meant by double decomposition?
Two substances break up from your
Give me a specific, don't use the word substances. That is an answer of an idiot. Double decomposition. Then two, what?
CuSO4.
I didn't ask you for the I just asked you to give me a specific name. Don't use the word substances. What will you call them? When
Double
two,
displacement.
huh? For double displacement. When two what?
Two compound.
Ah, okay. When two compounds, then don't talk.
Metal single.
Huh?
Metals.
This compound will always have metal. You can't have two non-metals like that. Come on. When two compounds, don't act like an idiot. Come on. When two compounds
react with each other with the compound with the metal in the high reactivity, which is more reactivity C. This places the one with the lower reactivity. The one with the lower reactivity goes to the substance, puts the metal with higher reactivity added the
do you understand your definition? You understood? Only you understood it. None of us have understood it. Will you please be serious and tell me I could get? Give me the proper definition of double decomposition. Do you know? Do you know?
I don't know.
Huh?
I don't know how to define.
Yeah, you tell me.
When two compounds in their molten or aqueous state exchange ions to form new compound.
Exchange ions to form new compound. Who starts the exchange process?
The compound which has a metal of higher reactivity.
Which has the cation. Don't use the compound because of ammonium is used and ammonium is not a metal. Ammonium is a metal. So you can say it has a cation more reactive than the cation present in the next compound. Okay, the interchange of cations and anions take place and a new substance is formed. Correct? Is this clear? Now, so that is your. Why is it called double decomposition?
Because like decomposition is happening twice.
It's happening twice between both the compound and the interchange of the ions take place twice. Is this clear? It's called double decomposition. Okay, now. Okay. Example of double decomposition that you can just read from the textbook. What is for a double decomposition? No, for a displacement reaction. What's another name for displacement reaction? What's the number name for a displacement reaction? No, for a double decomposition. It's for a double decomposition reaction. Yeah. No, double decomposition, double displacement reaction. It's also called what happens when a double decomposition takes place. What is the criterion there? What happens? Yeah, what do you get?
The precipitate is formed.
Either it is or
Salt and water.
Or salt.
it is neutralization. So the double decomposition is also called precipitation reaction or a neutralization reaction. Correct? Example: HCl and NaOH. That is neutralization. Precipitation. We can talk about say FeSO4 and the FeCl and H2SO4. You're getting FeSO4 and you're getting HCl. Okay, that is how you get your precipitation. FeSO4 being heavier will be precipitated. So that is a double decomposition. Now we come to energy changes in a chemical reaction. Now let us see a simple thing like this, okay? A simple thing like this. Suppose we have reactions like this. A, B plus C, D will give you now A, D plus B, C, correct? A is AD plus BC, all right? Is this clear? Now, AB, there's a bond here, okay? There's a bond here, there's a bond here, there's a bond here, and there's a bond here, all right? Now, what happens is, when this reaction is taking place, and you're saying what is chemical reaction? Chemical reaction is when the reactants react with each other to give you the products. What happens actually? You will find that there's a change in the physical properties. You'll find that there's a change in the chemical properties. You'll find that there's a change in the heat energy level. Okay, why is there change in the physical and chemical properties here? Ian, tell me, why is there change? Is it true that there is going to be a change? Why? Because new substances are formed, they have their own properties, own chemical, physical properties, and the energies are changing. Okay, where has that energy come from? The energy is
from the exchange of electrons.
no. Energy is
It has come from like breaking and forming.
rubbish. Energy is already present in them in the form of potential energy. Everything has got potential energy, potential, everything has got its own potential energy, which is referred to as chemical energy. Because it's chemical reaction. If it is you're using the energy to run, kinetic energy. The energy keeps on changing, but each one has come with its own energy. Correct? So therefore, you have got your energy, and this energy has now become chemical energy. Now, what has happened, or what is happening with that chemical energy? The bonds have to be broken. The bonds have to be broken. A has to be broken to A plus. Bond is to be broken. Is that plus? Huh? The bond is broken. Then you get B set free. Then you get C set free. Then you get D set free, and then you get your A plus your D set free plus you get B set free and C set free. All these are ions. They're all ions. How did they become ions? That chemical energy, okay, these, using the chemical energy, kept on absorbing energy from the system and broke the bonds. So the energy was utilized to break the bonds. And the bonds broke. And they kept the ions free. And the ions are moving and mixing up, positive and negative, and they're getting a product. As soon as the bonds are broken, what happens to that energy? It has to be given out. Why should that energy be given out? Why was that energy?
Because like after the reaction, energy should be given out. Because like if energy is still present, it will bring again.
Yeah. Why was the energy first of all taken in? Why was the energy increased to break the bonds? Now the bonds are broken. Why do we need the energy? It has to be given out because the energy is still there, but the bonds will not join. For the bonds to join, you need less energy. For the bonds to form, you need less energy. So the energy has to be given out. If the energy is still there, the compound of your products will never be formed. So the energy has to be given out. That is why you have endothermic and exothermic reactions. So depending upon whether the energy is accepted or the energy is being given out, you have got your endothermic and exothermic reactions. Is this clear? Now you know why reactions are called endothermic and exothermic, why heat is absorbed, why heat is given out. Heat is absorbed to break the bonds. As soon as the bonds are broken, the heat has to be given out because the bonds have to be joined. If there is heat, the bonds will not form. Joining will not take place. They will be still far away from each other. The constituents. All right? Got that now? So because of this change, you have got endothermic and exothermic. In an exothermic reaction, okay, heat is given out. Heat from where? In an exothermic reaction, the reactants have got high energy, while the products have got low energy. In the endothermic reaction, heat is absorbed. So here, the products have got high energy and the reactants have got low energy. In an endothermic reaction, products have got high energy, reactants have got low energy. In an exothermic reaction, reactants have got high energy and products have got low energy. Just remember one thing. If you remember one, the other will follow. You know that in an exothermic reaction, correct, you have to absorb energy to break the bonds. Once the bonds are broken, it's given out. Correct? So that means energy was required for the reactants. So, exothermic reaction, reactants have got high energy. Products have low energy. Endothermic, products have got low energy. And reactants have got high energy. And ultimately, the energy drops in an endothermic reaction. Pay attention to my sentence. Energy is absorbed in an exothermic reaction. But ultimately, the energy of the system is dropping down. How can this happen? It's absorbing energy at the same time the temperature is dropping. How? What temperature?
After some time, it will release its energy.
Rubbish. Not at all. See the textbook here. Read your, it is on page, all of you got this paper.
Yes.
All of you got this book, no? There's this book, page 35. They state endothermic reaction. almost at the end of the page, they have said here, it causes a fall in temperature. It causes a fall in temperature. Have you got your book? Which book? Dalal. Anyway, the statement is it causes a fall in Dalal. Have they mentioned that in an endothermic reaction the temperature falls? Has it been mentioned? Not mentioned. Now, what temperature? Whose temperature falls? How can the temperature fall when you're absorbing heat? You absorb heat, no? Then how will the temperature fall? They mention here it forms, it causes a fall in temperature. The definition is a chemical reaction in which heat is absorbed is called endothermic reaction. It causes a fall in temperature. In an endothermic reaction, total energy content of product is more than that of the reactants, which I told you. Whose temperature is reduced?
The surrounding.
Of the surroundings.
For example, photosynthesis, like it absorbs heat and
Yeah, the temperature of the surrounding drops. Why does the temperature of the surrounding drop?
because the
Because
reaction
it is absorbed.
absorbs
Because the reactants have gone and absorbed the heat. They did not have enough of heat within themselves. The energy within themselves, the potential energy, the chemical energy within themselves was not enough. So they had to absorb energy from the surroundings. So the energy of the system is warm, high, but the energy of the surrounding is cool. And why is the energy of the system high? Because it has absorbed the energy and it has contained that energy because that energy is supposed to continue with the reaction. The energy has been absorbed for the chemical reaction to take place. That energy will not be given out. It is stored until the reaction is completed. Is this clear? So the energy of the system is high. Why is it high? Because it absorbed the energy. But the energy of the surrounding is low. Is this clear? All of you got it now? Now read it. I finished that chapter. Now we go after we go to the next chapter, which is atomic structure. No, atomic structure. Which are the chapters for your first term?
first oil and last practical chemistry.
Yeah, practical chemistry I may not be able to have because there are
No,
many
it's
chapters.
okay. It's okay. It's very
Which is
easy.
the fourth chapter? Now I've done two
Atomic
already.
structure and water.
And water. Okay, I'll do water, and I should be able
Because
to finish
water is a bit. No, but water, half things are omitted. So
Anyway,
what?
come on, just read it. Let us see. You'll see what we can do. I'll start with atomic structure. Come on.
Yeah, can you explain this like?
Not necessary.
Ma'am, like our teacher told she gonna like ask the same thing.
When it comes in the exam.
Okay, I'll do that.
I have periodic table.
Yeah, even I give structure.
Atomic structure I'm doing now. Come on, again. But I don't know. For me, I am able to come. Your people stop coming for classes because their exams start. I will continue with the class.
Our exams 3rd of October.
Yeah, 3rd of October. When is your exam?
Next week.
Huh?
Next week.
See, she will start coming for class. She will stop. I will continue with the class. Come on. Let us now start reading till then. And then we will start with the atomic structure. Come on, someone read.
Ma'am, what will happen if we combine the products of an exothermic reaction and an endothermic reaction?
What will happen?
When we add the products of an exothermic reaction
Endothermic.
exothermic and an endothermic.
They're two different reactions. Completely two different.
No, like what if we add both of them?
I'm not able to understand your question.
Never mind. Little.
Just get a question and see which question.
So,
In periodic table. That if we are given an element and we have to find in which period and group it is. So how to find it?
Suppose you have got. You've got calcium. This is 20. Okay. So what is the electron number? 2, 8, 8, 2. 8 and 6 and 7.
Mom, it's 2, 8, 16, 32, right? Because our teacher said.
Don't open your mouth. Shut up.
Mom, our teacher. It's like the.
80
Electronic.
Idiot, if you have there 2 and 8 is 10 and it will become 10 here. Right? Flow commonly 20. This is the valency shell. Idiot, the valency shell can't contain more than 8 electrons. You stupid child. And you're arguing. Don't ever contradict my explanation. In the middle of my explanation, don't you interrupt. You're confusing a child there. You have a doubt, you call me privately. Your teacher told you and you're this way. I don't want to know what your teacher has told you. And neither will you tell your teacher what I have told you. Correct? 2882. Correct? Now, this last one will tell you the valency. This is the last valency. So if it is 2, it is in group 2. If it is in 2, it is in group 2. And 1, this is the first shell. This is the second period. This is the third period. And this is the fourth period. It is in the fourth group. 1, 2, 3, 4. Fourth period. Fourth period and second group. Okay? Fourth period. Okay? Fourth period and second group. That is how you come to it. Is this clear? Have you finished reading?
We have in the chapter.
Have you finished reading?
Yes.
Page
I have
92. It was there.
You want the scale on the back?
Have you ever finished reading that?
Yes.
Ma'am, in the water chapter from only 3C and Nagari.
It's only this
In
cover.
the semester, from 3 in water chapter,
Yeah.
only soft and hard water is there. That's it.
The rest was there in the first chapter. It's they have divided the chapter.
So that means you won't get that in the second term.
No.
Okay, then I'll leave you to finish it up. And see, you have to come for the class, but if you are not going to come for the class, then it's your problem. I am continuing. I will teach the whole chapter because the ultimately will come for the final exam. Well, first one, second one, that's the final exam. No?
Yeah, but like the omitted parts are not gonna come.
Definitely they have not come in the first term, or the second term also.
Yeah, those are that atomic 30s are not coming.
Yeah,
The
that
whole
is.
first part is not coming.
Yeah, okay. Have you got it now? Have you finished reading?
Yeah, he's smart.
Huh?
He's smart. He's omniscient. This whole page is not there. This whole page is not there. This is not there.
Except in the second half. I'll ask you questions for the first half only. Okay, now. Now pay attention here. Let us go to these questions. Let us go to the questions of the textbook. Choose the correct answer from the options given below. Which of the following is not a chemical change? Close your books. All of you close your books. We will write the questions in the back of the chapter. Close your books. All of you close your books. All of you. Come on. Which of the following is not a chemical change? Rusting of iron is magnetized, potassium is dissolved in water, magnesium wire is burned. It's not a chemical change. That is
Rusting
in
of,
line.
no wait, can you repeat the options?
Iron, rusting of ions, iron is magnetized.
Iron is magnetized.
I have not finished. Potassium is dissolved in water and magnesium bar is burned.
Iron is magnetized.
Okay. Heating of zinc nitrate is a dash reaction. Displacement, combination, decomposition, and redox.
Decomposition.
Decomposition. Next one. Burning of a metal is an example of decomposition reaction, combination reaction between the element and the compound, direct combination reaction between two elements, displacement reaction.
The burning of metals.
It is burning of a metal.
It is direct combination.
Direct combination between two elements, that is the metal and the oxygen. Next one, formation of white precipitate on mixing sodium chloride solution and silver nitrate solution is an example of combination, decomposition, displacement, double decomposition.
The option again.
Combination, decomposition, displacement, double decomposition.
Double decomposition.
Double decomposition. Now look, a brown substance A on heating in air turns black, forming another substance B. Substance A and B are Fe. Now this is a bit tough. Okay, I'll do another. Which of these is the chemical change? Water changes into steam, dissolution of sugar and water, combustion of LPG, liquefying of ammonia.
Combustion.
Combustion of LPG. Which of these is the chemical change? Combustion of LPG. The reaction of neutralization is a displacement reaction, double decomposition, combination, or combination reaction between two compounds.
Neutralization.
Yeah,
Double decomposition.
very correct. Then here, FeS plus H2SO4 gives you FeSO4 plus H2S. Is an example of displacement, double decomposition, decomposition, or combination.
You repeat the reactor.
FeS plus H2SO4 gives you FeSO4 plus H2S. See double decomposition. Now here, which of potassium chlorate, I don't know if you read the textbook or not, is an oxidizing agent, reducing agent, both reducing as well as oxidizing. All options are correct. Potassium chlorate.
Can you repeat the options?
It's an oxidizing agent, reducing agent, both oxidizing as well as reducing, all of the above. Both, no. It's an oxidizing agent only. In the reaction, manganese dioxide takes part in the reaction. It acts as a catalyst. It decreases the speed of reaction, helps in producing more oxygen. In the heat, in the manufacture of not ammonia. In the manufacture of oxygen, manganese dioxide takes part in the reaction. It acts as a catalyst. It decreases the speed of the reaction. It helps in producing more oxygen.
Can you just repeat the options?
It takes part in the reaction. It acts as a catalyst. It is yes, it acts as a catalyst. What happens when a solution of acid is mixed with a solution of a base in a test tube? The temperature of the solution increases. The temperature of the solution decreases. The temperature of the solution remains the same. Salt formation takes place. What happens when a solution of acid is mixed with a solution of a base? See, temperature remains the same, temperature decreases, temperature increases, or salt formation takes place. Then you are not bothered to be just skip one mistake. I'm not saying that the temperature doesn't increase. It is, but between these options, the most correct one is it forms salt. That is the closest. There are others also which are right. I'm not saying it is not right, but you will not give you full marks. Because the actual right answer is salt formation.
We will visit. All of the protein.
Name a carbonate that does not decompose on heating. Yes, Dhruv. Name a carbonate that does not decompose on heating.
Potassium carbonate.
Doesn't decompose? You're just guessing, you idiot.
No, because it is higher in reactive, like highest in reactivity series. So it doesn't.
Potassium nitrate, you said? What you said?
Potassium carbonate.
Yeah, it is correct. Potassium and sodium carbonates are very stable to heat.
Did you
Correct,
guess?
correct, very correct.
Did you guess?
A nitrate which produces oxygen as the only gas. A nitrate which produces oxygen only as a gas. You don't know. Who else? A nitrate which produces oxygen as a gas. It produces a nitrate produces oxygen as
Potassium
the
nitrate.
only gas. As the only gas.
Ma'am, potassium nitrate and sodium nitrate, both.
One moment. Nitrate which produces oxygen as the only gas. Yeah. So you have KNO2 plus oxygen. KNO2. Because KNO2 is not a gas. When KNO2 is a precipitation.
Potassium nitrate
And oxygen.
sodium
is
nitrate
oxygen.
too.
Sodium nitrate also, yes. A compound which produces carbon dioxide on heating. Yes, Ian. A compound which produces carbon dioxide on heating.
AgCO3.
Huh?
AgCO3.
AgC, silver carbonate.
No, CaCO3.
CaCO3. A nitrate which produces brown gas on heating.
Huh?
A nitrate which produces and beg your pardon, please
Potassium
repeat.
nitrate.
How you begin?
Sorry, ma'am.
Are you sleeping or what? Or do you think you're in your home or do you think I'm your grandmother? This way you're saying,
No, sorry.
which is the nitrate which produces a brown gas on heating?
Potassium.
Potassium nitrate, finished. What is a photochemical reaction?
Ma'am, it's my turn.
You are answering for everybody, that's why I don't want to ask anything. You want to answer, you keep your mouth shut. What is a photochemical reaction?
A reaction in which light is given
That is given back to you or to me?
in the to the reactants.
Give me an example of photochemical reaction. Give me an example of a photochemical reaction.
Decomposition of HCl. It's something to do with HCl. In diffused light, if you give diffused light to it, it decomposes, and if you give direct sunlight, it is explodes.
Correct, you. Next one. Give an example of electrochemical reaction.
Water.
Okay, what? Give an example where heat is evolved. In a reaction where heat is evolved. You,
N2 plus O2 equals at 3000 degrees Celsius gives NO2 plus heat.
N2 plus
O2.
is NO2.
Heat is also added, and heat is series.
Okay, you,
K plus potassium plus water.
potassium plus, yeah, okay, fine. Evaporation of heat, gets that. Absorption of heat, the heat is absorbed. A reaction with heat, yes, you.
Formation of water gas like C plus H2 gives CO plus H2.
Formation and absorption, heat is absorbed. The heat is given out.
It's photosynthesis. In photosynthesis.
Photosynthesis is not heat, photosynthesis is light, you idiot. Photosynthesis is light. That comes under specific light, not heat. The light gives heat, don't argue with me because I'm not going to waste my time arguing. To be very specific, I said heat,
Endothermic reaction, right?
absorption of heat,
Yeah. So formation of ammonia.
formation of
Formation of ammonia. N2
formation of
plus
ammonia. So, but then absorption, yeah, okay, fine. You get your yeah, between 150 to 200 degrees centigrade. Okay. Then you, and then any other example?
Now there are many examples.
Yeah, very simple example, continuously they are using it. Any other example where heat is given out, the heat is absorbed during the formation of the compound. Yeah, very simple one. You yourself have given that example.
CaCO3.
CaCO3, an absorption of heat, which is
Yeah,
calcium oxide
calcium
and
oxide,
carbon
carbon
dioxide. High pressure is required, yeah.
High pressure.
Hmm.
Again, a formation of ammonia.
Ammonia. Why does the blue color of copper sulfate solution fade on adding iron filings? Why does the blue color of copper sulfate, yeah, AN, fade on adding iron filings?
Minus.
Give me the answer.
What's the question? Question?
Why do you, what were you doing when I was telling that question?
Asking for what?
No. Give me one hard rack. Come and sit here. Think you're very funny? You think you're very funny? Why does the blue color of copper sulfate solution fade on adding of iron filings?
Because the sulfate, because in copper sulfate, the iron is fixed to the copper.
Yeah, because in this reaction, iron replaces copper in copper sulfate and forms iron sulfate, so the color fades. Give an example of single displacement reaction. Single displacement reaction.
Iron plus copper.
Yeah, okay. Double displacement. What is another name for double displacement? Yeah, or big double displacement is the question. So then you can't give me any example of double decomposition. Double decomposition. Double decomposition. Huh? H.
AgSO4.
AgSO4.
AGS. No.
FeS plus H2SO4.
AFES plus H2SO4. What will you get?
H2S plus FeSO4.
H2S plus FeSO4. Okay. Then photochemical reaction.
AgNO3 will give us AgNO2 plus
AgNO2 no.
Ag plus NO.
Thermal decomposition reaction. Thermal decomposition reaction. What do you mean by thermal decomposition?
Breakdown of a substance with the additional heat.
Heat. So give me an example of that where heat is added to a substance to break up. What do you mean you don't know? I've given you so many examples. Simple example with this girl has given.
CaCO3 plus heat gives CaO plus CO.
But it's
That's what?
reversible.
CO2.
And thermal decomposition is also reversible, right?
Thermal decomposition. A decomposition, no. No, a decomposition reaction is not reversible.
No, it was written in the textbook, I guess. I read it. Can I check?
CaCO3 will break up into CaO plus carbon dioxide. Carbon dioxide goes into the air. So how will it be reversible?
I guess CuSO4.5H2Y.
That is different. That is different. Okay? Not calcium carbonate, no. Now, electrolyte decomposition reaction.
2H2O in the presence of electric current gives 2H2 plus O.
Combination reaction between two compounds. Combination between two compounds.
Ammonia plus HCl gives
Ammonia
ammonium chloride.
will give you
Ammonium
ammonium chloride. Okay, fine. What do you understand by chemical reaction?
Chemical reaction is that when two or more products combine together to form one or more products.
Two or more products. Pay
Two or
attention.
more reactants combine to form a product, one or more products.
Can you give me more? Can you elaborate more on the chemical reaction? That is just the what else? What else? It's a 4-mark question.
Products will have a different chemical or physical composition than its reactant. There may be a change in state, change in color, gas may be evolved, or a formation of a precipitate.
What is wrong with you? Will you please repeat his answer? Huh? Why you can't pay attention? Why? Why don't you go home? You're not paying attention. So go home. On the contrary, you're irritating me by making that noise. And I'm revising this chapter for my benefit. But I don't know chemistry. Because I don't know chemistry. Give an example of a reaction involving change of state. Change of state. Next, change of state. Change of state.
H2 plus O2 gives H2.
H2O. H is gas, oxygen is gas, and H2O is water. Formation of a precipitate. Formation of a precipitate.
CSO4 plus Fe.
Cu.
SO4 plus Fe. Fe is so you get CO at the bottom.
Okay, correct. CuSO4 plus Fe gives you FeSO4 plus Cu, precipitate is formed. It is what is the precipitate? Initially double decomposition. Initially double decomposition. Now if your teacher is going to be very strict, she will not give you this because it's not double decomposition, this is displacement. This is displacement. But it is agreed. Because they didn't say, they just said formation of a precipitate and the precipitate is formed. Here, you get copper, huh?
AgNO3 plus HCl.
AgNO3
Plus
plus
AgCl plus HNO3.
AgCl plus,
AgCl plus HNO3.
yeah, so which is the precipitate?
AgCl.
Yeah.
Milky white precipitate.
Milky Way precipitate. And HNO3 is the acid,
Yeah.
nitric acid. Now, an exothermic reaction and endothermic reaction involving carbon as one of the reactants. Hydrocarbon combination.
What is just like C
An
plus
exothermic reaction, and an endothermic reaction involving carbon as one of the reactants. So here you have to give me two reactions. One is an exothermic reaction and one is an endothermic reaction. An exothermic reaction involving carbon, exothermic reaction involving carbon. CaCO3 involving carbon, not carbon dioxide.
now hot coke C plus H2. Yeah.
Like in formation of methane, can we say that like endothermic?
Yes, you're cooking something, isn't it? So that methane plus carbon. Okay, and you're getting carbon dioxide. It was burning carbon, and it is what type of a reaction? It's giving out heat. That's how your food is getting cooked. That's how your food is getting cooked. Exothermic reaction. Endothermic reaction involving carbon as one of the reactants. Endothermic reaction.
Now the formation of water gas.
C plus
Formation of
Water gas in industrial process.
water gas. So what is carbon monoxide? That is carbon monoxide. Water gas is what? Hydrogen and carbon monoxide. I said carbon, I didn't say carbon monoxide. The carbon. Water gas is carbon monoxide.
C plus
Carbon
H2O
as reactant.
C plus
H2O hot coke. Like,
Yeah.
Carbon as a reactant or product.
Carbon as a reactant.
reactant.
So hot coke C plus
Hot coke. So you're going to get coke, that is carbon, is used to break up water. You are getting it. Hydrogen is a breaker and carbon, part of water gas. Part of it.
the first.
Yes, that is part of it. Now, a reaction where color change is observed. A reaction where color change is observed.
CaCO2 plus
Yes, you are supposed to say it is that much you know. Why is energy involved in a chemical reaction? Why is energy involved in a chemical change? Why is energy involved in a chemical change? Can you give me the explanation? You, I'm looking at you, I'm not cockeyed. I'm looking straight at me. I, keeping my one eye is there and one eye is there somewhere. I told you I'm the most beautiful woman in this world. I'm looking straight at me.
Can you like repeat the question once more?
Why is chemical energy required in a chemical reaction? My God, yes, okay, please.
as,
No,
break,
say okay.
as breaking of bonds and forming of bonds. As energy and emission.
Explain properly the way I explained to you. Other than blacken your face with all those, with those what was the pen?
Marker.
Marker pens. Come on.
Japanese bullet tip.
I got. Tell me, what is the role of energy in a chemical change?
Energy is released when bonds are broken.
Energy is,
Released when bonds are broken.
but first of all, for the bonds to break, you need something. No, you talk start with that. No.
There's
What is?
potential energy.
See my question. What is the role of energy in a chemical change? Very important question. Why is energy required in a chemical change? First of all, is it required?
It is required to form bonds.
It's required to.
Form bonds.
Energy is required to form bonds. Definitely not. Definitely not. Can anyone give me explanation? Yeah.
Energy is required to break up the bond between the
What is wrong with you? My God, what is wrong with these children? You want to go home, you go home, and then I go home. I'm fed up of this class. Continuously telling you, behave yourself, behave yourself. You think I'm playing the fool here? So what are you doing there?
I'm stuck with a rubber.
Why are you playing the fool with the rubber band?
You asked it. It was here. You took it.
I think we take the class, tell them what you want to do. You can go home. I'm not interested. You're not interested. I'm not interested. I go home. Not bother. Go home and enjoy yourself. Fight with other bands, fight with whatever you have to do, because I'm getting fed up. If people are not bothered, why should I be bothered?
अरे बोलो तुम लोग भाई तुम निकल से हमारे
You ask her about that.
निकल जा 10 मिनट रुक के जाओ
अबे 10 मिनट में जाएगी जाएगी
अरे जा चल 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 जल्दी चल अच्छा है इट्स गुड ना गुड
अबे
So only poles got confiscated.
हाँ
So only poles got confiscated.
और
Old bikes.
और
Very serious.
ऋषि का
A chemical change involving iron and hydrochloric acid illustrates a dash reaction. A chemical change involving iron and hydrochloric acid illustrates a dash reaction.
Displacement.
Displacement, right?
Because iron displaces hydrogen.
And you have one element and a compound. That's the typical characteristics of a displacement reaction. In the type of a reaction called dash, two compounds change their positive and negative radicals. Not you, that does the back. Double displacement, double decomposition. Correct. Okay. Which of the following is not a characteristic of a chemical change? Not a characteristic. It is irreversible. No net energy change is involved. New substances formed involve absorption or liberation of energy. Not a characteristic of a chemical change.
No net energy.
No net energy change is involved. Okay? Okay. Decomposition brought about by heat is known as thermal decomposition. What is the difference between thermal dissociation and thermal decomposition?
In thermal decomposition, the compound breaks up into its constituents and the reaction is irreversible. And in thermal dissociation, the reaction is reversible and the compound breaks up into its ions.
Ions, very correct, very correct, very correct. What kind of a chemical reaction is synthesis? Support your answer with a example.
Got the name. Synthesis.
What type of a reaction is chemical reaction is synthesis? Support your answer with an example. Do you know?
It's the first type of reaction.
It is a
When
what type of a reaction is it first of all?
I can't recall the name, but I know the definition.
So give me the definition.
Okay, so when two or more reactants form one product.
How do they form? How do they form?
By when heat is exposed.
By chemical combination.
By combination. Give me an example.
2H2 plus O2 gives 2H2.
Okay. What is meant by synthesis? What is meant by synthesis?
It's a combination.
It's a combination. Okay. All right. Now, when hydrogen burns an oxygen, water is formed. When electricity is passed through water, hydrogen and oxygen are formed. Name the type of chemical changes involved in both the cases.
First, it is synthesis reaction,
Correct.
and the second is what was
Decomposition. What type of decomposition? Electrical decomposition. Very good. Now, okay, now who will give me this now? Metal X was placed in lead nitrate solution. Metal X was placed in lead nitrate solution. A very thin layer of lead metal deposits on metal X. Which is more reactive, metal X or lead? State the type of reaction and give an example of this type.
Let's
Metal X was placed, a thin layer of lead deposits on metal X. So who is more reactive, metal X or lead nitrate?
Metal X.
Metal X. Okay. And what type of reaction is this? Displacement reaction. Okay. Go and write down this equation on the board. Potassium, go and balance it. Potassium iodide, now see, write down this equation and write down the answers. Question I'm giving you, rub out. There's no interesting. Rub out, that will clear the board first. Ki, potassium iodide plus chlorine, potassium iodide plus chlorine will give you KCl plus I2 plus I2. Now, write down the equation, write down the questions here. Balance the given equation. Balance the given equation. What type of a reaction is this? Balance the equation. What type of reaction is it? Next one. Which element is more reactive? Third one. Which element is more reactive? What will be the product formed if KCl reacts with I2?
Huh?
What will be again? Huh?
Sorry, mom. Sorry, I have mom. Can you
What
repeat
will
the
be the
question?
product formed if KCl reacts with I2? If KCl reacts with I2.
Yeah, done.
Wait, work it out. Now come on, Papa, the whole thing.
Yeah.
Yeah, put that inside iodine.
What type of reaction is this? Huh?
Direct combination.
Direct. But I was saying displacement, how displacement, who's displacing what? What is being displaced? Who's displacing what? Huh?
Chlorine and displacement.
How can chlorine displace water? How will a gas displace a metal?
Chlorine is displacing iodine.
Chlorine is displacing. So,
Non-metals also have-
chlorine, iodine, chlorine.
Ma'am, I've done the
Yes,
balancing.
you can say,
Balancing is already-
one moment KCl plus I2, balance the equation 2I, 2K, 2I, yeah, and Cl2, correct, the equation is correct.
And the
Next
second
one.
answer is direct
What type
combination.
of reaction is it? Direct combination? No.
No?
Chlorine is displacing iodine. Chlorine, bromine, iodine. See the reactivity series. Chlorine, bromine, iodine. So chlorine is displacing. Always remember in a displacement reaction, one is a metal and one is a compound. One is an element and one is a compound. I told you that. So here
It's
element is,
displacement.
it's a displacement reaction, not direct combination. Displacement reaction. The chlorine is displacing iodine. See chlorine in the reactivity series. See chlorine in the periodic table. Chlorine, bromine, iodine. So chlorine is more reactive than iodine. So it's a displacement reaction. What type of reaction? This is displacement. Which element is more reactive? Chlorine.
Chlorine.
Chlorine is more reactive than iodine. Chlorine. Yeah. What will be the product form if KCl reacts with I2? If KCl reacts with
Yes.
I2, again,
It will, it'll, I don't know.
what will be the product? Who will tell me what will be the product?
The reactants be the product.
Huh?
It is a
There
reverse.
is no product.
There is no product form
Okay.
because iodine
Iodine
cannot
cannot
displace chlorine. Chlorine can displace iodine. Iodine can displace chlorine. So it will be end of the reaction. There is no displacement because there is no highly reactive element. Chlorine, iodine cannot displace. See here. No reaction. Iodine cannot. The single one has to displace the one from the compound. Iodine is not more reactive than chlorine. Chlorine is more reactive than iodine. See, these type of questions will come to you that I always have to write down each and every, work out each and every question from this book. I'm an idiot. You all are very intelligent people. You are the ones who are very intelligent. In this, I do not know how I'm getting less marks. He said, I do not know how this is happening. I do not know how that is happening. Sit down and just smile and play and pass your time. Everything will fall into your lap. Aram say. Don't worry, don't study and don't learn. Don't bother. Don't pain yourselves. And then come and ask me questions. He said, I do not know how I got such less marks. You're asking me instead of asking yourselves how you have got less marks. Maybe I'm a bad teacher. I think that is correct. I'm a bad teacher, therefore you are getting less marks. You are a very good student. I'm the bad teacher.
Shall I erase this?
Yeah, erase it. Go and balance this equation. AgNO3 will give you Ag, NO2 and oxygen. Go and balance the equation. Okay. AgNO3 breaks up into Ag plus NO2 plus oxygen. And write big. Don't waste time. Hurry up. We'll give you Ag plus NO2 plus oxygen. Quick. It's almost getting time. Before the bell rings, I want it explained. AgNO3 I said. We'll give you Ag plus NO2. Ag plus NO2 plus O2. We'll give you Ag plus NO2 plus O2. We'll give you Ag plus O2. NO2, sorry. Ag plus NO2. The very first one is wrong. Ag plus NO2. It's only 2 minutes more for the bell to ring. Ag plus NO2 plus O2. Yeah, okay. Close your books. Next, we will come to
Please give me 5-star. Sure. But I will give you these points because I don't have better students. 5. Wait, 6, 7, 8, 10. Well,
Because you don't get short, right?
I will give you this 10 rupees.
Would be short. Yes, I wanted to buy the green short. I would be friends. Yes, I wanted to buy like 18 friends. Each short. Would be short.